This is it. The new report. And it's a report we're particularly proud of this year. This is the fourth time we're releasing this report, and we started it a couple of years ago, analyzing the enormous amount of data we have to share that knowledge that we are building every year with you as the audience. And this year particularly, I think there's some very important findings in the report. Let me go through. So this is me, that's Magiel. And so you see the amount of code that we're analyzing is quite enormous. Last year, the numbers were already quite impressive, but we're very happy that this year we're crossing more than 300 technologies, which is a nice benchmark, and there's an enormous amount of 70 billion lines of code. And this gives us such a unique perspective on the market because it's global data, it's across technologies, it's across regions, it's across industries, and this gives us a very nice view on things that are going to happen. And I'd like to point out that today you will hear a couple of things that if they don't make you change your mind on how to deal with software, you should reread the report. I really think there are some very key findings in here that should have you rethink the way you deal with specifically open source. Open source is used by, there's some estimates that say that 80% of all code in production is open source. And a lot of focus is on trying to manage the other 20%, but please also pay attention to that very important 80% because there's a lot of bad things happening there, as we will be showing you. So the key observations here, obviously we'll share with you what the current state of affairs is, how the industries are performing. We'll share with you that we really believe that the industry, so that's you and us all, we need to up our game with respect to this open source. There are some really pressing issues that are asking our attention, and that also requires us to have a shift-left approach, meaning that we need to identify those issues way earlier in the process rather than reacting when things go wrong at the end. So let me hand over to Magiel, who will bring us to the first part of our analysis.
Thanks, Luc. So what we traditionally start off this report with is a sort of overview, a helicopter view, you could say, of the industry with these graphs. So what we are doing, we are analyzing these 70 billion lines so far every year, all the way back until we started with this, to give an indication of where things are going, right? Is the market starting to do better with respect to software quality, or are things going worse? Basically, you could say it as the climate development in software. A lot of graphs here, a lot of lines. The blue one in the middle is our core metric called maintainability. Basically, how well can you keep this system up and running efficiently and cost efficiently? There are a lot of other ones that are sort of underlying and more detailed. So the overall observation is that the market is not doing that bad. So since about 2015, the global build quality keeps actually going up. You could say that's very good news, and it is, right? Because things are changing. Like 10 years ago, we really had to stress to clients and vendors, start unit testing, for instance, start automating your tests. That sort of practices starts becoming common, right? And people tend to do it automatically. We still need to remind them now and then. It also means if you want to keep up also with your competition, you have to keep improving, right? You have to, because this is a relative benchmark, things are going up, you need to keep up with your peers, you need to keep improving your software. That's the message here. One of the biggest increases we're seeing in this purple line here is the modularity metric that we use. It's one of the underlying metrics. So that means architecture of systems is actually improving quite a bit more than the others. Software is also trending to become smaller on its own, which is a very nice effect. The big monoliths of the past are still there in some cases, but the new software tends to be a lot smaller. Okay, so then it's time to reveal one of the things we are traditionally also including, a ranking of the industries. So we split out this database in various ways. One is by industrial sector. Here you see the bottom 5, so financial services, software, computer services. And from there on, actually, the industries are performing below market average. So 3 is our number for market average performance, and it ranges from 1 to 5 in the total. So on number 5, we have government, which is a very stable performer. You see no mark here, meaning it stayed that way, and it actually staying there for many years. There's a lot of systems in this sector, a lot of growth as well. We're seeing more and more government systems that are small and tend to be of higher quality than the legacy systems that were there. Then we have insurance and banking, who both dropped a position. A lot of innovation tends to be happening also in banking, a lot of low code, for example, being implemented. But they've lost out this edition to a big comeback from the energy, oil and gas industry, who moved up 4 positions. Because basically we've...
Drum roll. Wow.
Yes, the drum roll. Well, if you read last year's report really well, you know who's going to be on number 1, because nothing changed there. It's the industrial transportation sector who is performing really well. So with that said, congratulations to companies industrially transporting goods, for example, railroads, ports. We see some fluctuations that are due to this window of time moving forward. Government is very stable, and here the numbers are very, very close, so we're seeing some changes now and then in the ranking. Going to technology stacks, another important... Yes, very briefly?
Quick question. What's the difference between financial services on one hand and insurance and banking? I would expect.
Well, yeah, mostly the banking license. Financial service can be a lot of startups and a lot of things around banks, and insurance is clearly only insurance. Another sort of slice we make through the data is by technology stack, where you see obviously legacy 3GL, 4GL languages at the bottom. Don't underestimate that category. It's actually number 2 in volume, right? So a lot of code is still there. And it's obviously also below the 3.0 mark. You want to move away from that category, obviously. Everybody wants that. Easier said than done. Moving up, we go to scripting and mobile technologies, which are relatively new and relatively small per system. Then we have Java, so the ecosystem of Java with a lot of other technologies doing way above average. And then a good contender, number 1 for a few years now, the low-code category, where you are able to develop applications relatively quickly. They stay relatively small. And still sort of on the back of our minds is that this category might go in decline a bit if these systems go bigger. So that's always something to keep in mind. We're not saying build everything in low code here either, right? This really depends on having a good fit between the functionality that's needed and the technology. These categories, they swap places now and then because of very minor differences in the scoring. And as I said, legacy is still there. It's number 2 in volume, right behind, I think, Microsoft.NET technologies are the most numerous in our benchmark. All right, with that said, let's move on to the next topic.
Yes, the so-called ticking time bomb. Everybody knows of the examples, and if you don't, then you should, of somebody recently told me there was one programmer who developed open source software who became a communist and said, well, you can't use this software commercially anymore. And all of a sudden, a lot of software that was depending on this piece of technology can't be used commercially, so that has to be rebuilt. Or the famous log4j issued of a couple of months ago that all of a sudden popped up. This is something that is happening every day. And it's something that will happen tomorrow again, and the week after. Now, if something literally happens tomorrow, that is by coincidence. Let me say this. And this is something that we need to be aware of. And the interesting thing is, as Magiel will show you in a minute, that we can know this up front. Now, all the methods that we have that people are using to prevent issues from happening is to implement systems that look at, once it goes wrong, to be as quickly as possible to say, oh, there's a problem, you need to fix it immediately. That is after the fact. You need to be as much as possible before the fact. Try to prevent these issues from happening. And as Magiel will show you, there are certainly possibilities there.
Yes. Let me start by showing this rather complicated-looking graph. But I will plot this line in here just for reference. This should not be here. This lump here indicates that most of the open source packages that are in use by our clients, this is data based on 1,000 client systems of us, are updated. This is the time scale, mostly after a year, or even 5 years is there. This lump should actually be moved, and a healthy situation should go that direction, and software that is being used should be updated when newer versions become available. Typically, there are good reasons such versions become available, like security problems, fixes for some kind of error, or other reasons. So this is the sort of the distribution we expected when we started looking at this data. This is coming from the open source health module that we have in SIGRID that tracks for our clients what open source packages they are using, what version, and whether there are any known problems with those. So we started looking at that, and we're actually shocked to see this. This is not what we expected. We really thought, okay, people really make a good effort and have a rational process here going on that prevents this. So most open source is updated in years rather than in days. And another realization for if you don't know, because these problems that Luc mentioned are not happening just because smart hackers find out ways to do it. These problems exist in these packages. And maybe 1 in 10 packages that are currently in use actually have known vulnerability problems, yet they are still in use, and they're still being used and downloaded by people. Actually, 40% of downloads of the Log4j example that Luc mentioned are still vulnerable versions. So people don't update their code. While it's actually, in many cases, not so hard to do. It can be as simple as updating a number, and then a new version will be applied. If you have proper testing, that can easily be done. In some cases, it's a lot more work, but it's almost always worth it to fix security problems that otherwise can be exploited. I'm going to drill down a little bit this data, how it, what could be the reasons and what could be potential ways to fix. One of the things we looked at, and this is a very similar graph, here's again the time it takes to update something, and this is the chance that it has happened. So we're tracking here about 150,000 library versions that our clients were using in the past year, and there we have two classes, two lines. So the bottom one is for libraries that are sort of kept in the source code without any automated management. This can still be done. You can just copy in some code and keep it there and use it. That's the unmanaged part. This is the managed line, the blue one, which is sort of using a package manager or automated tool to handle your libraries. That's what you obviously should do, because it's typically 2 times faster. So those libraries that are managed automatically are 2 times faster. This practice is still pretty common, that people do it in an unmanaged way. Sometimes even IDEs, so development environments, make this happen. You should really become aware of it. In many cases, you can actually extract this information very easily from a tool. Open Source Health also tells you, and replace this with proper management tooling. Another reason that we thought up front, it might matter how big the security issues are. If it's a very critical problem, or if it's a very, it's sort of a medium risk problem, that might make a difference. So people that become aware of a critical issue, they might want to update faster. Well, again, we have a time to update graph here, and we see that it hardly matters, much to our surprise. So whether it's critical, which is the purple line, you don't even see it because they overlap so much, or if it's a low severity problem, the sort of the time to update doesn't really change. So developers are either not so much aware of the severity of problems, or they're not equipped, maybe. They're not allowed, maybe, to update their libraries quickly. There can be many underlying reasons. The effect is that 70% of those libraries are still in use. even if they're vulnerable to a critical problem. That doesn't sound good. In all these cases, security fixes are available because these known security vulnerability reports are published after a fix is made available in the sort of the ecosystem. So it's always possible to update. It might be a bit of work, but if it's a critical vulnerability, that's always what you should do. Then another one that is pretty close to our other service where we measure the quality of software itself, the software of the quality of a system really determines whether you can actually change that system, right? If you have a very badly written piece of code, it's hard to do anything with it. The same happens to be the case for this updating frequency. So here again, the same sort of plot, and we have 3 lines, one for the 2-star systems in our benchmark, the 3 stars, and the 4 stars. So obviously, 4-star code correlates with faster updates. It's faster, it still only gets to 40% here, right? So 60% still doesn't update fast. But at least with higher quality, you tend to update faster. So very obviously that is what you should aim for. This is not new advice from us, right? It's what we always say. There are many reasons why you should do this to be cost efficient, but updating is part of that, right? This is part of maintenance, something you should do. A bit of a different finding, but I would say the most important one from our report this year. And in the benchmark report, we describe in detail how we got here. We had the intuition that the quality of code, right, as I was telling about systems before, also applies to the libraries, right? So it doesn't matter what the quality of a library is compared to if they're vulnerable or not, right? So you would expect bad code has a higher chance, a higher risk of having vulnerabilities in it. Well, that is what we tested, and you see the result here. And it's an important result because the difference is quite big. In the middle, we have 3-star systems, about 3,500 of them. And, sorry, I have to say libraries. These are open source libraries that we've measured. We apply the same tooling we normally do on systems to the libraries. And we checked if they have a vulnerability. Then we compare the risk to the 4 stars systems that are obviously a little bit lower. But at the 2 stars, the risk is almost 2 times as high as in 4 stars. That's the major finding. Meaning, not only your own code matters, the quality of your own code, basically whatever you use, whatever you pull in from the open source world, really determines whether you will be at risk from, for example, security problems. This is a rather new thing because there's no tooling or platform available at the moment that really shows you the library build quality of all the things you use. Well, we have something to reveal. Yes. This is where I hand it over.
Yes, so maybe this is a good moment for the audience to phone the development teams and if you want 5 minutes break to inform how are we doing things, are we indeed managing things through package managers, how are we dealing with the update frequencies, are we really this bad or is this just an anomaly? Well, this is the data that we have collected over many years, this is not an anomaly, this is the fact of the matter. So we were actually shocked by these results. We were expecting some findings, but these are way more extreme. Of course, as a supplier of these kind of services, it's nice to have something impressive to say, but as a fighter for a healthier digital world, we'd rather see something else. This is not something that we were expecting, and it's really something we would like to draw your attention to. So try to automate this process much more than you do today. Have a look at this, this process, have a look at this library, and be sure that you understand that bringing in something like Log4j is sort of an accident waiting to happen. Because if you look at the build quality of Log4j, it's actually quite bad. It has a very low quality. So you could have expected And this is something that happens today in development teams, obviously, because there's not like a management team that should be deciding on which library that should be using, but there needs to be awareness of that kind of relationship. And that's something we really like to draw your attention to. So maybe with that said, some thoughts on how to move forward.
Yeah, because we're spotting problems here and things we don't expect, that we didn't expect. So what we are advocating and what we're hoping to help make happen is sort of, yeah, it's a commonly used term, shifting left, essentially means being more in control of the process, so that you prevent, for example, weaknesses for security, you catch them earlier, and you also are able to mitigate them fast if you find them, meaning in the development process. So we're building some things in our R&D that will land in SIG through the open source health and the software security modules by making this information available earlier. So I'll show some results from our FASTEN research project, which has been going on for 3 years, where we are able to track and mitigate weaknesses more accurately than what is currently available. And we're running a project called Scramble that will implement better security code review, with better meaning easier for people to execute. I'll tell you some details, because security expertise, the people that actually need to do that are very, very scarce and hard to get. Importantly though, I told you white lie earlier, so because we had really thought this finding is very important, we need to do something now and show at least library build quality somewhere in SIG. And so we implemented this in our open source health analysis, where you can see, hey, this is for some particular open source library. You can now see its library build quality there to give you an initial indication. This is not where we will stop, because we think, well, you should get awareness of these issues, but you should also get some tools to treat them by going to a higher level, essentially, and have an overview of your portfolio, for example, where you can see, okay, these are all the libraries we're using, they're so-and-so big, they have this quality, and they have these risks, so that you can make a good plan, right? So that development teams can then get some guidance on that and also provide their input on it. That's the one thing, so this is to zoom it in a little bit. This is what you can see currently, and there's more to come in this direction. Secondly, we really believe in looking at code as we have for 15 years, but then pointing out the problems in that code that will be a problem later on. So one of the things we have built in the recent past that is currently available in the software security module is a new benchmark that differentiates between the type of system you have. Some systems run, for example, like in a server, like maybe they are in a cupboard somewhere and they're not accessible through the internet. That's a physical system. Then there are systems that are on the internal network. They might be connected, or they might actually be public facing. And that really has a bearing on how bad software weaknesses are. So what we do here, we use tools to detect weaknesses, so-called CWEs, and we score them using a lot of input from expertise, from CVSS scoring, to provide a standardized score for each of these weaknesses. So if we spot a weakness in code, we figure out what is the type of system you have, and then we can position that on this range here, from low to medium, high, and very critical. So that you know, okay, if this is critical and I have a public-facing system, then you really know something needs to happen, and that problem needs to be fixed. This is currently live in SIG. This is a result from the FASTEN project that I was talking about. So it is able to, through a database of call graphs, so-called call graphs for all the libraries in Maven, PyPy, and Debian, which are the ecosystems for Java, for Python, and for C. we're able to stitch together, is what the process is called, from where the application starts. So these are the yellow boxes, all the way through several other packages to, for example, in this case, the log4shell vulnerability that we have analyzed with these tools. So this gives developers the ability, for example, to say, okay, if we have this going on, you might want to fix it there. You might want to mitigate that problem by checking for it. And in this case, actually, here's also an application, so you need to look. You could upgrade the library as well. You can also figure out, hey, are we really vulnerable to this problem? Or are we not using the part of the library that is vulnerable? That's what these tools allow us to do. And then finally, some words about Scramble. So Scramble is also a relatively recent research project that our security practices is running, where we focus on making the process of manual code review in security easier and more, let's say, efficiently executable by security practitioners. So we strongly believe that security should be designed into a system, which means it needs to happen early, before code is even written. You can start with this, but definitely if code starts to get written, security review needs to happen, and it needs to happen in an effective way. So this Scramble project builds a knowledge base of where you need to look if you are a security reviewer, connect that to the actual code base, and point people in the right direction. So a big trend right now is that tools are used for this, so automated tools. But what is a fundamental problem with those tools is that they don't cover everything. They have fundamental blind spots that you need to mitigate by having people in the loop and having them in the loop efficiently so they look at the right findings. So we're doing R&D on that, and actually we're really looking forward to collaborating on trying such new techniques out with our clients or with people in the community. All right.
So, we've bombarded you with data, with nice graphs and some not so nice graphs. Well, as a graph they were nice, but maybe the content wasn't. All of that is assembled here, and we really like to urge you to think about this, what you're going to read. This is going to be available, of course, to everybody. For those that are not present but online, it's downloadable. But there is a need to invest more in this area. There are serious risks that we're all running that we would like to avoid. We gave you some indications, some hints, some thoughts on what you need to be doing, but this open source issue is a pressing issue. Again, 80% of all production code is open source, and it needs to be included in your thinking. And we also know that there is an enormous shortage of expertise, which is why we're implementing and researching all ways to make this much more efficient. For now, I'd like to thank you for your attention and invite you to read this report at ease. And if you have any questions, let us know. Actually, if you have any questions,
yes,
let us know.
Yes, let us know. We're opening for the QA now. So people here, of course, in the audience, if you have a question, we have a microphone available so that also people online can hear your question. And people online, if you have a question, please use the QA function to address the question. I'll get them here on the laptop and I can ask them to the presenters to answer your question. So is there a question at the moment in the audience? Maybe not yet.
Totally shocked.
Shocked by all the numbers, I can imagine. There was a lot of data, yeah. But really good presented. Thank you for that. I have a couple of questions from the people online. Some of them are very particularly, very specific. So some of them we will not address all on stage right now, but we will get back to you after the symposium. I have one question that I think is really interesting. Magiel, you addressed, of course, a lot about open source health and what we should do and we should improve as management as well, what questions we should ask our teams. But what does a top fit open source user to you look like?
Right. Yeah, that's of course the $1 million question, right? So how should it look? I don't think you should only be a user, right? Open source is there, you can use it, and it tends to be for free, right? You can, with the right license, you can use the code and benefit. But that has been the mode for using such libraries for like 10, 20 years, maybe longer. That's where the change needs to be, right? You need to also give back, right? You need to ensure that the projects that you really rely on are healthy. And maybe you can help them. Maybe you can invest in them. Maybe you can give them advice. Maybe implement a tool. I don't know. There are many possibilities. And you need to increase your own awareness, right? That is rather obvious. That's what we're recommending to, have a good portfolio overview of these things. Yeah, something like that.
Okay, good. I have another question online that I think is nice to share. So first of all, excellent presentation. So kudos to everyone here on stage. A question from my side. Besides quality of actual code, what is your view on the quality of architecture when it comes to software?
Well, you saw Magiel presenting that the architecture is obviously very much driving the overall quality, but you did see from Magiel's data that the metrics we're using on architecture are improving. Well, maybe you can.
But that though that's the system scope, right?
Yeah.
And I think architecture does include these open source problems as well. And these are architecture decisions. Which open source do you use? And for that you need to lift the analysis. You need to look higher than the systems, and you need to, have a stronger decision making on that.
Yeah. All right. Questions from the audience? No? Oh, yeah. Yeah.
I'm digging in to the shift left movement as well, from another perspective. To what extent could code signing be a solution to prevent all this horrible stuff with open source library?
So with code signing, you mean people, they put a stamp on it that it's their code and...
Yeah, but then in an automated manner.
Right. Well, to an extent, and there are some issues I think in the list that Luc started with that apply there, like maliciously inserting code somewhere. However, many vulnerabilities are because actual functionality is being exploited. For example, this happened in the Log4Shell. That was not really a bug. That was actual functionality that people built, and that was later exploited. So I don't think that will solve it completely. Some classes there would help. Yeah.
All right. So for the sake of time, I would like to have a warm applause for Luc and Magiel. Now we're going to move on to the next presentation.